Hey Stephen, I'm going to show you a couple examples I wrote for you. Your email, I kind of read it two different ways, so I'm gonna make an example for each of the ways I kind of understood it. The first possible thing I think you may have meant is that each time you push a button, you want to switch between two outputs. So you got two outputs. The first time you push it, output number one will come on, and two will be off, and then you push it again, and two will be on, and one will be off. So something of that nature. So I've written that, and that's what this is, and I'll just kind of walk you through it a little bit. So we've got the first thing. You come from the start block. You go to this debounce subroutine. What that does is it takes care of mechanical bounce for you. So our PLCs run at a very high speed. Frequently, they're around 5,000 scans per second, which is great. It can do a lot of stuff for you. But one thing you might encounter as a result of that is mechanical switches and buttons. They, if you were to look at them under an oscilloscope, if you were to zoom in on what's happening, you'd see that mechanical transitions, are rarely clean transitions. Frequently, they bounce up and down a couple times on their way to, whether they're being turned on or turned off. And our PLCs happen to run fast enough that you can encounter that. So this debounce subroutine, which you're welcome to dig into, it's pretty short. But what it does is it basically makes sure that a signal is steady for a certain amount of time. In this case, I've got it set up to 50 milliseconds, but you can change that by just adjusting that one number there. But in order to use this, you don't have to understand the debug subroutine much at all. Okay, so we're doing this. We pass in one of our input bits, which is C1 in this case, and what we get out of it is I'm calling it debounce C1, and we've taken care of making sure that we've eliminated that possible bouncing response. So we can use that from that debounced C1 throughout our program here and know that it's a good clean signal. Okay, so what we're wanting to do is you're wanting to switch the outputs based on a rising edge transition, which is a transition from where you're saying the button wasn't pushed and now it is pushed. So we're going to ask the question, was the last time we went through this routine, was it off? That's what this block will do. And if so, is it currently on? And then we know it went from off to on, this most recent scan, and then we're going to do something. And the way we create this last scan C1 is at the end of each scan, we're going into this copy routine. And we're going to copy the value from that debounce C1, and we're going to copy it into this last scan C1. So it's ready for its next scan. So we can always compare to say, hey, have we just transitioned from off to on? If so, we're going to ask. We're just asking, was output 1 on? If so, now we want that one to be off and output 2 to be on. And if it wasn't, then let's turn output 1 on, and we'll turn output 2 off. And we just go through this routine. So you can see I'm putting it into debug mode here. And you can see if you monitor these, I'll put the switch right next to the mic so you can. Oh, I'm sorry, I need to turn on the value. Okay, these are the ones we're paying attention to. So you can see each time I click, it transitions to the alternate. And okay, so that's basically one of the possible things I think you might have meant in your email. I'm going to pause this video and come back with the other possible interpretation. Okay, and here is the other possible thing I interpreted your email to mean. So the idea here is that you will be pressing a button, and when you do, it'll cause it to go into a state where every so much time the outputs alternate on and off. So in this example, I've made it so that every second it'll go from output 1 being on, output 2 off, to output 1 off, output 2 on. So it'll flip every second. Or if you push the button again, it goes to a state where they're both off. You press it again, and then it goes back to that alternating every second mode. So I try to keep it looking pretty similar. We're now using a state machine, so I'm initializing a state to 1. And we've got other examples on the website about state machines if you're unfamiliar with this. Again, the first thing we're doing is we're wanting to debounce that input signal. We have we're checking for that rising edge again, just like we were, but this time we're instead of asking if a particular output is on or off, we're going to say, are we in state equals 1? And state equals 1 is going to be where we're just, you see here, state equals 1, then we're going to turn both the outputs off, and we're going to hang out here until the rising edge transitions, and we ask if state is equal to 1, then we're going to move it to state equals 2, and when that happens, you'll see that we start a timer, we turn the output D1 on, output D2 off, we reset that timer, and then you see we advance the state to 3. This whole thing's a big loop, just like all of our state machines. You can't quite see it over here, but there we are. You see it all loops around, so it'll come back here, it'll go through this again. It'll now be state equals 3, and we're going to ask if the timer, if 1 second has elapsed in the timer. If it has, we're going to switch the output values. We'll move to state equals 4, or we'll hang out there for a second, at which point we're going to jump back to 2, and we'll repeat the cycle. So I'll show you what this looks like. I'll download it, run it, and we'll look here. And you see state is equal to 1 right now because we told it to start out in state equals 1. And in that state, you see both of the, I'm sorry, it's on the right side of the equation, both of the outputs are zeros. So they're both off. Now if I flip the switch, you'll start seeing them alternate. Okay, so you see them going back and forth. If I flip the switch again, they're going to go back to 0. And they'll just hang out there until I flip the switch again. And now they're going to be alternating. So I'll send you both of these programs, and let me know if you have questions.